Hi, I'm John Good from PBC Linear. Today we're going to discuss contamination, fine particles, and appropriate linear bearing selection. To quantify what I mean by fine particles, I have a table which describes some common objects and what their relative diameters are. As an example, we're all familiar with human hair and how fine it can be. A typical human hair is approximately 60 microns. In contrast, when I refer to a fine particulate, something like Portland cement, which is roughly the same texture as talcum powder, you're dealing with a particle that is approximately 5 microns in diameter. Now let's go ahead and discuss bearing selection in this type of an environment. In general, a plain bearing is typically applied in these applications because there are no moving parts, versus a ball bushing, where the two most common failure modes are contamination or a lack of lubrication. But as we look at plain bearing alternatives, let's contrast how a bronze bushing versus a Teflon-lined plain bearing would operate. To highlight this, I will be using Portland cement, which has a particle size of roughly 5 microns. So what I'm going to do is we're going to go ahead and compare free running operation without these environmental challenges. Ball bushing works fine. Now I'm going to go ahead and take these bearings. I'm going to place them in Portland cement. A little bit of shake and bake, if you will. You'll see we've got all types of particulates, both on the OD and the ID of this product, and yet it continues to operate. Let's contrast that. A bronze bushing, same sequence. You will see that I am having to force this over the shaft almost to the point where the product is hard bound. Why is this? It relates back to running clearance. For both of these bearings, we're dealing with a running clearance that is in the range of 5/10,000ths, pretty small. Why is it that the Simplicity bearing continued to operate, but the bronze bushing, we literally had a binding take place? To illustrate this, let me go ahead and reference a diagram that may be helpful. This is a cross-sectional view of a Simplicity bearing. The yellow indicates a Teflon liner that provides self-lubricating characteristics. But in addition to that, although the running clearance is 5/10,000ths, we're able to go ahead and accommodate fine particles get trapped in micropores while continuing to operate. In addition, as illustrated here on the leading or trailing edge of the bearing itself, those particles tend to go ahead and gather. They almost act as a secondary wiper to keep additional small particles from becoming trapped between the inner diameter and the OD of the shaft. Now, in contrast, the bronze bushing, which also had a running clearance of about 5/10,000ths, because it's a hard material with no give, it ended up resulting in the binding that you saw. In summary, Simplicity bearings are an excellent choice if you have any one of the following characteristics. Extreme environmentals. That could be fine particulates, as we've talked about. Temperature extremes, -400 to +400. Temperatures that you might see in a sterilization operation or in a washdown. Large loads. Dynamic loads where there is shock, where you would not want to go ahead and be exposed to the potential catastrophic failure of a ball bushing. And then finally, the inherent lubricating maintainability characteristics that come as part of the Teflon liner itself. So, I'd like to go ahead and thank you on behalf of PBC Linear. Have a good day.